Hello, everybody, and welcome to week 4 of Scripting for Designers 3. So weeks 3 and 4, I know we talked about this last time, last Monday. There's the NPCs and a manager, which was covered Monday, Sneaky Sneaky, which for this month, nobody showed up to the Wednesday lecture, so just going to want to watch the previously recorded lecture for that, and we'll talk about it a little bit more today. And there is a discussion, kind of almost wrapping up the class. There's one more assignment for going further with Unreal AI. Talk about that before we get into the sneaky topics and check all that out. So this assignment will have you actually go to the Unreal Learning courses and stuff like that. It's basically directing you to additional research to do and continue on, go a lot further with some of the basics stuff that we're introduced to for this month. And we'll be talking about it a bit more, but there is several resources that you'll be directed to with the AI and blueprints, and going a lot further with the behavior system than we have for this course. So for it, you will actually be required to go to the course and learn Unreal Engine and complete it up to at least 50%. Ideally, you should run through the entire thing. It's not too long. And then take a screenshot just showing us that you have used that external research for the class and are running through it, not just clicking a button saying, I've done it. All right. So today, we'll be mainly focusing on the sneaky stuff. So Project Sneaky. We'll take a quick overview of it and then take a look at a couple of the topics required for it. So there's two parts to this. There's the instruction sheet right here, as well as a rubric and feature sheet that you'll need to fill out. Never happened in COD games. All right. So the two separate sheets, this feature sheet, you'll actually be filling out and adding additional comments to some of the features that you may have implemented slightly different than the instructions, or adding a quick comment. So when the person's grading it, if you struggled on a certain section or almost had one of the sections complete, you can add that comment in here and let us know, and we'll be sure to give you additional feedback for that specific feature and things. But the sneaky project in general is defined in this the instruction document here, or assignment document, whatever you refer to it. Talks about the general stuff. You will be just continuing off of your previous assignment, that NPCs and a manager. You can create a brand new project and then just import the state machine and stuff again, so that you are using a state machine for it. Talks about just general setup, so that you need to have a terrain, use just primitive shapes for the blocking and stuff. Please do not import any additional packages or a bunch of different textures. They will bloat the project up too much to submit on FSO. So please try and keep things simple, just a simple color for the different stuff. You could do Supergrid, absolutely. I'm fine with that. Just watch out to make sure that the package size doesn't get over 500 megabytes, which Supergrid I think will only bloat it up to about 60. So should be fine there. It describes some stuff to watch out for when as you're going through it, and talks about what you'll be delivering, as well as like how we'll be actually grading the different features. Does it functional? So no matter what, as long as it's working, that's good, but does it also take into account proper state machine functionality, where there's helper functions are the actual enter, execute, and exit, or enter and tick and exit, all being used properly so that the states are doing the functionality versus everything being on the agent and the state is just there as kind of a nameplate. Are the transitions implemented properly? Does it transition when it should? Some of that is up to interpretation, as you as a designer have control about what states it could transition to when certain keys are pressed. Say you have it paused, but the player gets near it. Would it automatically switch to starting to chase the player, or would you allow it to stay in that pause state? There's a few things that you'd want to do to figure out what states would allow it to transition to what. And those are all those exit conditions that we were all talking about in the last discussion stuff. The rubric requirement sheet, which we saw just right here, you will want to actually download this. So once you are viewing it in the Google Drive, you want to click those three dots. Chat got in the way. Actually download it, and you'll be submitting this along with the normal full-on package of the project. This is not just a screenshot assignment. We will be grading the entire project itself. Once you have it downloaded, you'll be opening it up and editing it as you're kind of going along. I highly recommend having it open while you are working on the project. And internet, no. But here we go. And once that opens up, enable editing for it. And as you go through the list and are completing the different features, go ahead and add an X for if it's feature complete. One thing to note about this, if you made any attempt on any of these features and got it even partially working and stuff, still mark it as feature complete here. And then maybe add a comment about what parts you didn't get working, and that'll allow us to come in during grading and give you additional feedback specifically for those things you struggled with. And so this explanation section is for you to fill out whatever you'd like as a comment to the grader. And this is how you'll be graded for each of the different tasks. Some of them are pretty much gimmies. If you have like the prefabs here, that is talking about a blueprint. Blueprint is the same thing as prefab. I do want to point that out. And I believe down here, it's got a copy and paste error because it's a similar project to the one we had set up in Unity. It is talking about Unreal for this class. So just ignore Unity and know that it is referring to Unreal. So these are all the tasks ahead of you. As far as what they are and things, you'll want to reference that assignment document. It has a full section on the implementation, the guard manager prefab and script. So a central object tracks those guards. Well, that's already done for us from that last assignment. So that's pretty much all done there. It talks about the left and right arrows. Keep in mind, it does include that left arrow where the assignment instructions only showed you how to set up the right one. I would recommend taking a look at the lecture. I do explain how to get the left arrow working on that as well. And then it talks about other input keys. When we press 1 is when it should change to the pause state. So for this game, we have some debug keys to allow us to switch those states on those guards. So there'll be 1, 2, and 3 to transition to certain things. When 2 is pressed, it should switch to a reverse state. So rather than going through the patrol path normally, I have an example completed project right here. If we just play it, this guard will go up to that top left, and then I believe top right. Let's see after he hits that one. Yeah, he's heading over to the top right. If I click in game, press that right arrow, we have that one selected. We're able to pause it with that 1 key, unpause it. If we press 2, it'll actually reverse and start going through that its nav point array backwards, or iterating through that array backwards. So similar to how that manager was set up with the right arrow going forward through the current agent selected array, we'd want to have some sort of check on the agent. Is it reversed? Then would want to change its color and do reverse. We also see that as it got close to the player, it actually saw our player here and is now going into a pursue state, which is represented by the magenta color here. And if we get too far away or lose a sight, it will stop chasing us. Stop right now. Yep. So the kind of premise of this game is you're supposed to sneak around while the guards are all patrolling and just kind of get past to the end of the level. I have this balanced so that I can kind of run past all these guards here. There is one other feature we didn't quite cover yet, and I also adjusted it so that they go a little bit faster when they're chasing me here. But I'll just tell that guy to pause. There we go. Using some hacks, just pause all the agents so they can't chase me forever. And there should be 4 separate areas. This little boss guy at the end, it's a lot bigger and faster than the other agents. When you actually get to an end area, there should be a trigger volume to let you know you escaped or you won or whatever. And that's the general gist of it. One of the states I didn't talk about is there's this little red object in each one of the rooms. That's think of that like the alarm object, which we'll pull up the instructions and see that. Haven't talked about that part yet. But the document also describes like what colors they should be when they're in the different states. Patrol is already green, idle was already set up for you with dark green, pause was gray. Saw how to do that in the last one and was supplied for the agents and a manager project. Angry is one of the states we have not talked about. Pursue we saw was that purple or magenta, and that's chasing after the player if it sees the player and stuff. But angry is a new state that we haven't really talked about too much. When we press the 3 key, it should trigger this angry state, turning red and moving to an alarm that's in the room. So the way I like to think about this game-wise is that you're a hacker kind of breaking into a building and stealing some documents from a big tech company or something, and you have to make it out all right. And you have this little tablet on your arm, and there's a little terminal in the room or something that you can hack with your tablet on your arm to make the guard go over to it. So that's what these little alarm nodes are indicating and stuff. So let's go ahead and select one, selected that first agent there. And when we press 3, it'll turn angry, have to go over to it. When it touches it, it just turns off the alarm and resets back to its normal patrol route. So it's kind of a way of distracting the guards. If we are in this room and I don't know where the guard is, there he is. If we want to pull him off his normal patrol route to give us a chance to walk past, we have that option. Same goes for this. If we tell him to get angry. Difficulty is pretty easy if we can just always spam this, but if this was a real game, there'd probably be a cooldown for the different features we can do when we stun the guards or pause them and stuff like that. But it's seeing how we could set up these different state changes and things like that for a game type scenario. You'll also notice that there is no lose condition whatsoever. So even if a guard catches you or is touching you for a period of time, we have no way of losing the game right now. That's just to help us with the testing purposes. We're really just looking at the functionality of the state changes, not setting up a full-on game that you would normally have, maybe like a timer if a guard's close to you or not, or something like that. So back over to the document. Angry, we saw there should be an alarm in each room. You should be able to issue a command to distract that guard and turn him angry and have him run over to that alarm. Pursue, we saw that should just chase the player after it's in a range. And one of the things we'll talk about today is actually player detection and setting up a basic player to move to. They all should have that nav point array, which is already included from the previous assignment. And patrol. So patrol has 2 directions. We talked about being able to press 2, turning kind of blue and go backwards through the array of nav points. When it is going forward through, the array should just be green. And when it's going reverse through that array, it should be blue. Nav point prefab or blueprint. Obviously, we have those. An alarm node is something new you'll have to add. A player script. We haven't talked about a full-on player here, but there is an example with a link to the previously recorded lecture here. We'll also demonstrate that a little bit today. The end goal is actually getting to an exit location or a simple trigger volume that outputs a "you escaped" message. Player does not need to have a state machine, so the player will just move to any point that you just click to get that moving around the world. And Here's a quick tip, make that exit location easy to click on. So for example, I've set up my game so that I can kind of come up here, and if I click just right there, my hands are nowhere near my keyboard and mouse right now, but it's navigating to that point I clicked on, which will cause my player to run through the entire thing and kind of test out that win feature. So it's nice to do that when you are testing things and setting up things in a functional environment like this, where you can just kind of click on the spot you want it to go to. It should navigate all around, stuff like that, to make testing a bit quicker than having to constantly click all the way through if we had all of these lined up in just a big old hallway and it's way over at the end. Then there's some additional notes in here about how some of the things can be set up. Reverse mode doesn't need to be necessarily a new state for the state machine, just a simple bool to say whether in the patrol state, whether it is reversing or not reversing, stuff like that would be a lot simpler than having to duplicate the patrol state over again and change things up like that. For submission, as I mentioned, you will be submitting the entire project. So you will be creating a zip of the config, content folder, project file, create that zip. You'll also be submitting that feature sheet as well alongside the zip or in the zip. Either way works as long as it's submitted with the project itself. All right. So that's enough general looking at how the project is going to be set up. Seeing how we could do the player setup and things like that, we'll be continuing off of our previous assignment that I demonstrated during last week's Monday lecture. And we'll just press play and see what this has in it. So right now we have no player. We're just in kind of like a spectator view. We can use those right and left arrows to select one of the agents. We got that agent and a manager all working. So we'll need to add some things to kind of give us a base for the sneaky project. One of the big things we'll need to add is a player. There's a few different ways we could do this. We could do it from the ground up to be able to like point and click where we're going to be, how we're going to be viewing the game, things like that. So rather than doing it all from the ground up, what I'm going to do is just import the top-down package or top-down template. Add a feature or content pack using the add new from content browser. And this will be a blueprint feature. They have a top-down setup that already allows for just the clicking around and being able to navigate, have that player navigate to the point we click on. That'll be our easiest setup. We'll add that to the project, but we will be changing it up a little bit. So it's not just that same top-down character as normal. We'll need to, character is an empty folder, nice. We'll go ahead and drag one of these characters in here. We'll also tell this level that we want to use that top-down game mode blueprint. So we'll go to settings. The world settings are per level. We'll make sure that it is using the top-down game mode. And since we just dropped this character in it, if we play right now, we see it spawned a character way up in the world, and it does, we are able to click around, but we already have one kind of placed in the world for it. We don't need to spawn another one. We want it to start controlling this character. We can select that character, hop over to its details, and way down towards the bottom or using the search, we can tell it to auto possess based on a player 0 or the first player. So once we have that, we should just start controlling that one rather than spawning a new one in. I'm going to want to adjust the camera from default because that's really up close, and we'll take a look at this blueprint, see how it's working, if there's anything we want to change. So we'll go ahead and open up that top-down character. Take a look at the viewport and zoom out. Obviously, there's a few different things here. There's two cameras. One is a VR camera and one is just a normal camera. We do not need a VR camera, so we're going to clean all that up and make this a little bit simpler to understand and customize it for our type of game. Let's just dock these tabs so I don't have multiple windows. So first thing we'll do, we do not need a VR camera. We don't need a second spring arm. Our spring arm 1 is just our normal camera or basic camera. The second one and the VR camera, we'll select those and delete them. We'll click compile and hey, it's complaining we just deleted stuff that was in use. So we'll let these errors kind of point us out where that's at. This is talking about if HMD is enabled. HMD, if you don't know, is for head-mounted display. Well, we won't have a head-mounted display in this, so we can get rid of that entire section. If we look at this, this tick is only being used to figure out if it was head-mounted display or not. So rather than doing a branch and then running this false stuff, we'll just go straight to that false stuff and no longer need the branch. All right. We have two of those already gone. We have this one still complaining because it was trying to activate that VR camera, just like we did with the tick. We don't need to check if it's head-mounted display or not. We aren't making a VR game. So we'll clear that out and make sure that it does just activate our normal camera. Reset HMD stuff, don't need that. So we're simplifying this blueprint down quite a bit. Down here, it was running this when it wasn't, it is still running this every frame. So every frame, setting world location and rotation. Well, what is this actually doing? So it's getting our player controller, figuring out where that mouse is, if it's hitting any objects in the world, figures out where that location is, and setting our cursor to world, which is that little decal for the green little icon showing us where we're clicking, and updating that as we move our mouse around on screen every frame. So we definitely still want that to run. All right, but nothing in here has any information about like when we click or how it tells the character to move. That's actually handled in the top-down controller. So we can see it's the controller blueprint handles clicking and telling the character where to go. Oh, let's check out that code and see how that's working. We'll start with the event graph. Always a good idea to check out what events they have. They have some touch events. Well, we aren't making a touch game or tablet or phone game. So we can clear out anything running from that touch stuff. Our event no longer needs that sequence since we got rid of the touch stuff. And we can just go straight to that enter. This is using a gate. Gate is probably something you might not have seen before, but it works kind of how a gate would. When it is open, that's when it'll run our exit. When it's closed, if it is told to run this enter and stuff, it will just stop at that. We see it's going to start the game closed. Every frame, it's going to try and enter that gate. So it'll be sitting here trying to enter. nothing will be happening. But we see as soon as we start pressing that, or we click our left mouse button down, that's when that gate opens and it starts running this exit. If we release the button, it closes the gate again and we'll stop running the stuff on the right. We see we do have another check if we're using a head-mounted display. So anything from that tree branch we can clean up or get rid of. Simplify it down. So yes, you do need to press that left mouse button down to get it to move. We'll just finish cleaning this up and then check out how that functionality is working. All right, so I've got that all cleaned up. Let's pull this out, and I want this visible as we're actually playing so we can see it in game. Compile, save. Back over to our level. Want that up on view while we're playing. If we play, and we will select our top-down controller as our debug filter so we can see when it's running this stuff. You see it's hitting that enter. It's every frame this stuff is running. If we press and hold our left mouse button down, we see that will constantly open that gate. It did the open when we first pressed it. And the gate is open now, so our character can run around as we're holding it. If we let go, it stops the gate again and will no longer update. It'll wait for you to actually like just single click, or holding it down allows you to move. So all our movement functionality is still there. Always a good idea to test after you are cleaning up some code and simplifying things down. Let's stop, and we're just about finished with that. We're figuring out where we actually clicked and then calling this move to hit location. This move to hit location, it does a little bit of a check to see, did you click far enough away from the user? There's a minimum click distance variable that they have set up. You have to click 1.2 meters away from our player to even get it moving. But then it uses that same kind of simple move to location that we saw before and are using for our agents to move. All right. So, any questions about how our characters got its movement set up or how that's all working from this? I know we were just using the template version, so it's mostly done for us. I just wanted to make sure you guys are understanding how that's working. Nope. Okay. So we've got our player moving and all that. Let's take a look at how the camera is set up. As of right now, like if we're playing this sneaky game, we can't really see too much beyond right up next to our player. So we're going to change our camera to be up a bit more and kind of like right above our character, as more of a proper top-down would be. Back in our character was where our camera was set up. We see it's kind of at a 40, 60 degree angle or something like that. If we take a look at our spring arm here, which is what controls how far, what camera angle and stuff we're looking at, it is -60. Let's go -90, so it's straight up and down. We can also adjust how far back it is, adjusting the length of the spring arm up. And to say why it's using a spring arm and why we aren't just setting this camera to a position, the spring arm allows for, like, if there's a ceiling or something like right here, it will detect that along the spring arm and pull the camera up to that ceiling rather than being on the other side of the ceiling. So you're just looking at like a floor of a second level. So that's generally why a spring arm is used versus just setting a camera position, because you don't have to take into account wall collision or anything like that. backfire at the player though. Yes and no. It's all dependent on how you set up the spring arm, how you lay out the levels to take that into account, things like that. So there are a lot of different options to adjust, and sometimes can be bad, sometimes are awesome when it's implemented correctly. All right. So I just pushed it up to about 1028. And if we look in game and actually preview this, we'll see we now have a top-down view, have a better view of the game world, not just looking in front of us and stuff. Probably would push this back a little bit further so we can see the agents when we're interacting with them. But that's good enough. We have a player. We now need to get these agents interacting with them. So we saw the sneaky asks for them to go to a follow state. I did represent a follow state being toggled off of a key press in a previous lecture. So you may want to look back through that and check that out. But for this purpose, I want it detecting the player just based off of when it perceives it. And rather than doing the follow state again and showing you that entire feature, I'll just be having them enter the pause state when it does see our player. So for this, we'll need a couple of things. We'll need our guards to actually be able to detect our player. There are many different ways you can do it. Simplest way is just a simple trigger volume. When another agent enters it, or the player enters that, have that thing toggle. But that won't take into account like any walls or anything like that, which I think my walls are a little bit short right now. So before we get started, I'm gonna make my walls taller so that they'll actually block stuff. So I'm gonna select all these walls, switch over to the scale tool, make them tall enough. All right. Save that. And for today's lecture, we'll just go into the more advanced way of doing this. Unreal has some really great AI tools built into it. So we'll be taking a look at it that way. So our agents will need to be able to start detecting other things. If we look at some of the built-in components, as I mentioned, we could just do that trigger volume or some sort of collision object on this that detects other pawns. Not the greatest way to do it. We're going to look at something called the AI perception. There is a perception system, and it goes hand in hand with stimuli sources. We'll do AI perception and adjust some settings for it. There is an older component that you may have seen for pawn sensing. That's a very old way of doing it, not very efficient. Definitely, I highly suggest checking out the AI perception instead. So there is a senses config. We can give it different senses, different ways to detect things. We're going to keep it simple and just set up it for sight. So there is site config. We can then expand this and adjust a whole lot of things. Site radius is 30 meters. That's pretty huge. We'll adjust those after we get this in game and working. One thing you will need to change for the senses is this detection by affiliation. By default, it's always set to detect enemies, but there is no good way of flagging what is an enemy, what is neutral, what is friendly. Site radius is 0 would definitely be blind for sure. But we'll use pretty much all the default stuff for right now. We do need to change it to allow it to detect neutrals as well as detect friendlies. We'll see why in a moment. And dominant sense, we could set that up. While we only have the one sense, we aren't dealing with any sound or damage detection. we'll just be using that site detection. All right. So compile and save. And our agents, the AI that are moving around the level, now have a way of detecting certain things. Those things we want it to detect, such as our top-down character that is representing our character or player. We're going to want to make sure this is giving a stimulus source to that AI system. So we're going to add that component. If we just look at AI, we don't need our player to have perception, but we do need to make sure that it notifies our AI, and we use a stimulus source for that. Stimulus source, we'll just leave this completely default. I'm sure that we'll may have to come in here and change that, but let's go ahead and hop it right into game and pull up our AI debugging and see what that is. So pressing the apostrophe key just to the left of enter, we'll pull up our AI debugging. And on here, there's different things we can press to see different stuff. If we press on the number pad 4, it'll turn on our perception stuff. If we press 4, and right now, it's actually displaying perception stuff. We do actually see a little dot of where it detected certain things. We see as soon as it's detecting this at site, and it just turned around and walked away, so no longer detecting. If we go ahead and fly way out of here, and we see this towards the edge, and I don't have my nav mesh going out that far. There was a little bit of the radius. So it's got a huge radius by default. It can see it way across the map. I'm gonna tweak that and bounce that down a little bit so it can't see quite so far. So on our nav agents for its perception, we'll definitely drop those down, not to 0 to make it blind or anything, but maybe a couple meters in front of it, or 3 meters, about 9 feet. So it can start seeing it 3 meters in front of it, and we'll lose sight if the player gets 3.5 meters beyond it. We can even adjust how far to the side it can see. 90 by default. We could get it more cone-like, just dropping that down 15 degrees, 45. 45 would be decent, but giving a lot more peripheral vision is actually preferred for this one, since they are like turning drastically when they're at their nav points. So maybe in the 70s range would probably work out a little bit better. So we'll do 70s. We could go into our agent and drop their speed. So on our nav agents, let's make them go a little bit slower so we can see this in action a lot better. Rather than 300, they'll move 100. Compile, save. And for simplicity, when you are testing out these new states, I highly recommend that you just use one agent at a time or things like that. I'll keep the 3 agents in there because they'll be fine. And you'll want to pull up that AI debugging to see any information because we're not responding to it right now. We'll pull on numpad 4, and we see a much better circle around our character. As soon as we get outside that range, that's when it stops seeing it. It does see it right now, stops seeing it, sees it again, and stuff like that. We could even turn off the normal AI so we don't have that nav mesh drawing. But as we can see, if we leave from a side angle and get behind it, stop seeing in front of it, we just get past that range. So I'd probably want to tweak this to a bigger range and stuff, but the point is we've got that functionality of it being able to detect us. Now we need to respond to it. So back in our nav agent, on this AI perception, if we want to see what kind of events and stuff we can do for it, we can just right click and see what types of events there are. On perception updated or on target perception updated. We'll go for add on target perception updated. So when it sees one of these targets, whether it just started seeing it or lost track of it, that's when this will run. We're given what other actor it's actually seeing, as well as a stimulus source. So this is a structure full of information about the stimulus change and stuff. We pull that up and we just break that structure into its individual components. We can see how old this source was, when it'll expire, the strength. There's a lot of customization you can get with this. We're going to leave all those default values so we can test some other stuff out. Big one we would want to pay attention to, though, is if it started sensing this. So successfully sensed is a bool that will change whether it first started seeing it or whether it just lost track of that character. So successfully sensed will come in handy. We'll want to branch off that. Another thing we'll want to do is we want to figure out what other actor it's detecting. So let's pull that other actor up and we'll actually just get the display name and print that out before we try and deal with getting it responding. Just print that string anytime this function runs and detects something. All right. So as we run in, we see if we get near one of these actors, it does start detecting, but it's not only detecting us. We see detections of the other agents I have in here, which I named last lecture to Mario, Bob, and Tim. We see they are all responding to that other one. So we really only want it to care about our player object, not necessarily seeing another guard. So for our character, or our player, essentially, and we're using our top-down character for that, I'm going to go up to the class defaults, or also just single-clicking this self object here will bring those up. Way down towards the bottom, similar to how we set up our nav points at first, we can add an actor tag to it. So under actor, we'll add a tag for it. Rather than none, we'll give it a player tag. All right, capital P, no spaces before or after. I'll save that. Then over in our agent, when it does detect that it saw something or something like that, before we try and do anything with it, let's check if this actor it's detecting has that certain tag. And we said player, capital P, no spaces. All right. If it does have this tag, that means we've just detected our player. So anything we connect from the true will only be when our perception is changing for our player. When it is changing for our player, the next thing we want to see is did it successfully sense it or did it lose track of it? So we now have when it sees the player and when it loses track of the player. Okay, well, when it sees the player, I wanted it to just change to that pause state is what I said. So we'll kind of like stun them when they do see the player, like a deer in headlights. We're in the nav agent itself, so we could immediately just grab our state machine, tell it to change to a certain state. Which state are we going to change to? Well, let's have it change to our pause state. And let's make sure that's working before we set up when it does lose track of the player. It's always good to test new things you're adding. If we get in front, pause that guy. That guy's going to see us as soon as it gets past this wall here. There we go. And that one should see us as well. If we leave though, all right. So we got that pausing working. It is responding to our player. We do see it's complaining it can't enter the same state. That issue right there. We'll take a look at the state machine, see where that's actually being printed from. We didn't make the undo. The undo was built into the last, or restore previous state was built into the state machine now, as of the last assignment. But yeah, yep. So we haven't done that part yet, but I do want to also explain where this cannot enter the same state twice. I don't like that. We should have it allow it to enter the same state multiple times so that it can just restart that state and run the enter again and things. Keep things simple. So looking in the state machine, if we want to find out where that was being printed, I'm going to look in the find results and just say exactly what that was saying. Cannot enter same state. So find results here. Cannot enter same state. We see it's inside a print string, the default value right here. I want to allow it to enter that same state, so it does call that state again. So we're going to change this up to, rather than checking if it is already the current state, just going straight through and allowing that enter state to run again and stuff like that. So we don't get that can't enter the same state again. File save. On our, let's double check to see if playing caused that same issue. If we leave, enter, we're no longer getting that just printing error. It is allowing it to enter that state again. That'll come in handy for when you are doing the switching to reverse. If you want, if it was already patrolling, call those functions again on that entering of the state once more. All right. So we do need to finish that off with making it sure when it does lose track of the player, it changes to, oops, our nav agent would be the one losing the track of the player right here at this false when it no longer successfully senses it, rather than changing to the pause, just like we had set up our toggling of our pause, which I probably do have a toggle pause here. We'll just tell our state machine to restore the previous state or restore previous state. Cool, that's what I called it. So this is similar to that back state that you might have set up 2 assignments ago. It's change name and it's just more accurate to kind of what it is. Go back to whatever state you were in. So we play, when it sees us, when we leave it, should go back to the previous state. All right. So any questions about actually using the perception? I know we didn't get too much into it, just saw how to tweak some values for it to see those in-game values, pull up the debugging for it, allow it to detect all around and when it loses perception and stuff. No? Fantastic. All right. So any questions in general about the task ahead of you? You will need to set up a level layout with like 4 different areas, like I was showing at the beginning example game. Anything about the assignment that seems unclear, or you might have you think you might struggle with? Okay. Well, if there's no more questions on this, that'll pretty much wrap it up for today. Just a reminder that to try and get started on that assignment like right after this, and we will be having lab today starting at 3. For the assignment, should you make a level like your project? So you guys are designers. The level example that I was showing off earlier was a very kind of basic level that just kind of had the same spot duplicated over and over. It is completely up to you how you lay out your level. It does have to have at least 4 kind of distinct rooms to it, and agents assigned into each one of those rooms. And but as far as how that level is set up, totally up to you. If you want to have it like a straight hallway, I like to throw in a few little random walls to make the player zigzag a little bit and stuff. But the level layout, as you can see, this first level is pretty much straight from the previous assignments and things. Then the next level has some basic rooms laid out. One thing I would like to remind you of is that this is a terrain, and you can hop over to the landscape and actually start sculpting it if you wanted to have some areas raised up and stuff like that, or even having ramps or second levels to your area and stuff. You can totally customize the level however you see fit. So at least kind of 4 distinct areas. As you can see, I kind of tried to make that a little bit more clear with this one with the different colored rooms. Like this is your first room, second, third, up, and fourth being the yellow area. So 4 kind of distinct rooms with an entry point and an exit point on them. And then that win area or the starting area would be additional to those 4 rooms if you wanted to have your player maybe start back in a cubby right here. But 4 rooms definitely with agents in each different section. So you will have to practice some actual layout of how things are set up in your world outliner to try and keep the different areas a little bit separate and organized, things like that. You'll want to take that into account. All right. Any other questions before I go ahead and close this out and upload this? Yep, 4 distinct rooms with agents that your player must get past. You don't need necessarily a starting point, and the goal could be in that last room technically, but if you wanted to get it a little bit more polished up like a game, you'd probably have your player start in like a safe area and then move into that first room. Same goes with the win trigger. All right. Cool. Well, if there's no more questions, I'll end it here, and I'll see you guys again on Wednesday. If I don't see you in lab today, lab will be opening back up at 3 for any questions you might have while you're working. All righty. Later on, everyone.